March 1945. The far side of the Rhine lay under a pale, washed-out sky, the kind of sky that made distance look endless. On the eastern bank, a German engineer stood behind a low earthen berm, boots damp from the morning ground. He raised his field binoculars and adjusted the focus with a practice motion. The lenses settled on a group of American soldiers at the water's edge. They had begun only minutes earlier. Klaus Reinhard checked the small watch on his wrist. He had noted the time when the first truck rolled up, when the first stack of unfamiliar steel frames appeared on the riverbank. Now the second hand crept forward, and he counted quietly in his head. 12 minutes since the first piece had been touched. 12 minutes, and already something resembling a structure reached out over the water. To his left, a young German private whispered a comment about how fast the Americans moved. Klaus did not answer. He shifted slightly, angling the binoculars for a clearer view. 6 men handled each frame.
No crans. No winches.
No visible concrete works. Just bare ground, steel plates, and soldiers working in tightly choreographed teams. His mind automatically moved from images to numbers. Distance between supports. Approximate weight of the frames. The width of the river at this crossing point. It was reflex, something trained long before he wore a uniform. He had once measured river spans to place elegant arches. Now he did it in his head, in the middle of a war. The river here was wide enough that no simple field expedient would do. A crossing strong enough for vehicles, possibly armored vehicles, required serious work. Normally it meant days of surveys, clearing, foundations, and then the slow rise of girders. Klaus had seen the process many times. He had drawn it, signed it, supervised it. What he saw now did not match anything he knew. He lowered the binoculars for a moment, letting his eyes rest. In the distance, the other shore looked busy but calm, almost like a worksite rather than a battlefield. Trucks arrived, unloaded metal frames, and departed. Teams of soldiers broke into groups, each moving with quick, unhesitating steps. No one stood around waiting for instructions. No one checked drawings. No officers waved blueprints. Klaus lifted the glasses again. A new frame slid into place beside the last one. The soldiers lined up its edges with the previous section in one smooth movement, as if they had done this routine 100 times. A few gestures, a tool raised, quick impacts, and the panel no longer moved at all. The river had gained another 3 meters of steel. He exhaled slowly. What they were doing should not be possible at this speed. He reviewed the assumptions he had been told the previous month at headquarters. Allied forces, British, American, Canadian, would eventually reach the Rhine. Every major permanent bridge along the river had been prepared for demolition or already removed. The calculation was simple. No large forces could cross without major bridges, and major bridges required serious work. Several weeks, at least, before heavy formations could move across in strength. Those weeks were supposed to be Germany's breathing space. Klaus glanced again at his watch and then back to the water. He did not feel nervous yet, only curious. The engineer in him wanted to know how this puzzle fit together. Somewhere behind the rhythm of movement on the opposite shore, there had to be a principle, a design choice, a logic that explained the impossible pace. He opened a small notebook he carried in his tunic pocket, flipped to a fresh page, and started to sketch the outline of the growing span. Short lines, quick notes, rough estimates. He wrote quietly to himself as the river continued to flow beneath an unfinished bridge that lengthened minute by minute. Before the war, bridges had meant something very different to Klaus Reinhard. He had studied civil engineering in a quiet German university town with red roofs and orderly streets. His early projects involved roads, municipal crossings, and small river spans for local authorities. He remembered running his hand along a newly completed parapet, proud of the clean line of the concrete, the symmetry of the supports, the sense that the structure was meant to stand for decades. His professors spoke of durability, elegance, and efficiency. A good bridge was almost like a public monument, quietly reliable, woven into everyday life. Then uniforms replaced suits, and markings on maps replaced city council sketches. When he had been recalled to active duty and assigned to military engineering, his first shock was not the uniform, but the schedule. There was no talk of 50-year service lives, no careful debate over aesthetics. A temporary bridge was expected to serve its purpose and then become irrelevant as the front moved. Some would be dismantled. Some would be left behind. Some would be damaged by artillery or aircraft. Function first. Lifespan, measured in days. Over 2 years on the eastern and western fronts, Klaus had helped to throw improvised crossings over rivers in cold climates, in muddy spring thaws, in places where frozen banks crumbled under the weight of vehicles. Wooden trestles had gone up over streams whose names he barely remembered. Steel sections had been pushed across canals whose water carried the reflection of burning warehouses. Pontoon lines had stretched over murky channels under low clouds. Each time, there were drawings, but they were leaner than in peacetime. Measurements were precise, but the goal was speed and sufficiency, not perfection. He learned the art of making foundations out of whatever was available. He learned to read soil with the heel of his boot and to balance load and risk under pressure. He also learned the other side of the trade, demolition. He had supervised the placement of charges beneath arches he might, in another life, have designed to last a century. A span that had taken years to conceive and months to build could be broken in a single coordinated moment. Railway bridges, highway overpasses, stone crossings. Each removed structure meant more time added to an enemy's advance. Time for units to withdraw in order, time to regroup, time to build a new line of resistance. This logic had shaped German planning along the Rhine. Permanent bridges had been removed or prepared for removal. Railway lines had been interrupted. Maps in headquarters were marked with symbols indicating where the river could no longer be crossed by heavy formations. The numbers were reassuring. Weeks of delay for any opponent trying to rebuild such capability from scratch. Klaus had believed those numbers. He had helped produce some of them. On the eastern bank that March morning, watching strangers in unfamiliar uniforms slide steel into place with startling speed, he felt the first small crack in that belief. It was not fear, not yet. It was the unsettling sense that the rules he had learned might be incomplete. He lowered the binoculars long enough to note a few facts in his notebook: estimated span length, approximate width of the structure, number of soldiers in each team. Then he wrote a single word in the margin: system. He did not know yet what that meant. The thought simply felt relevant. The crossing the Americans were attempting was part of a larger operation he knew only in outline. Rumors had preceded the movement of Allied forces to the river, a coordinated push with multiple armies, a significant concentration of artillery, aircraft overhead almost continuously. The name Plunder had reached his unit in briefing rooms where maps of the Rhine stretched across entire walls. Arrows, colored lines, dates. To Klaus, those sessions had felt both abstract and heavy at the same time. The river on the map was a blue stroke. The river outside now was a broad, cold current. The German plan, as he had heard it, relied on delay. Major crossings were to be denied by removing permanent bridges. Engineer units like his were to make sure no structure remained intact that could carry tanks or long columns of trucks. In the calculations presented to them, the absence of these fixed points created a predictable gap for the opponent, time that could be measured and used. At one briefing, a senior officer had pointed at the map and tapped a spot along the river. If they want to move serious weight across here, he had said, they will need thorough groundwork. Foundations. Piling. Heavy equipment. You cannot support an armored formation on improvisation. They will require at least several weeks before they can move significant forces over a river like this. Several weeks. The phrase had echoed through many subsequent conversations. Now, lying on the damp earth behind his observation point, Klaus compared that assumption with what he observed through his binoculars. There were no signs of machines drilling into the riverbed. No piles driven into the depths.
No tall crans winging massive girders.
Instead, there were low stacks of identical steel frames and a constant flow of human movement. He watched an American team pick up one of the frames. 6 men bent, lifted, and carried it forward. Their steps were careful but unhurried, like workers on a factory floor. They dropped the frame into place, if dropped was even the right word. The movement was firm but controlled, a practice motion that ended with the frame perfectly aligned against the existing structure. No tape measures appeared. No chalk lines. The holes on one frame met the holes on the next as if the pieces had been designed to recognize each other. Klaus adjusted his notebook sketch. He began to mark the size of the frames in relation to the soldiers' bodies. From that, he derived approximate dimensions: length, height, thickness of the steel. He had done this sort of rough scaling many times before, estimating profiles for damaged bridges from photographs and reports. Here, he was building a picture of something entirely new to him. Another frame followed, then another. Teams did not wait for one group to finish fully before positioning the next unit. Work overlapped in smooth layers. While one set of soldiers secured fasteners on a fresh section, another team was already bringing forward the next element. The structure did not emerge from one point outward. It seemed to grow in multiple adjacent zones at once, like a line of factory stations arranged along the riverbank. This arrangement made sense when he considered the task in abstract. If every part was the same and every connection familiar, work could be divided and repeated. The more he watched, the more the scene resembled not a traditional construction site, but a production process that happened to be stretched across water. Klaus checked his watch again. The thin second hand moved steadily. The span was approaching the midpoint of the river. He realized that at their current pace, assuming no interruption, the Americans would establish a functional crossing far ahead of the timeline that had underpinned German planning. The thought settled in his chest with a weight that had nothing to do with steel. Curiosity now sharpened into professional focus. Klaus shifted his attention from the overall span to the smaller details that made such speed possible. Through the binoculars, he examined a single frame as it lay on the ground waiting to be lifted. It was a rectangular lattice of steel bars, arranged in diagonal and horizontal lines.
No decorative touches.
No extra plates. Everything about it suggested calculated simplicity. He traced the pattern in his mind, imagining how force would travel through it when loaded. Along each end of the frame, he could make out rows of circular openings. They formed a pattern that repeated from frame to frame. Same spacing, same position, same size. When a new section was brought against an existing one, those openings met perfectly. Soldiers did not have to search for alignment. They pushed, held, and within seconds another man slid fastening bars through the holes. A few strikes from a handheld tool seated each bar. An observer unfamiliar with engineering might see only noise and motion. Klaus saw something else: elimination of variation. Every joint followed the same steps. Every fastening point looked identical. He thought back to the bridges he had designed early in his career. Each crossing had required custom elements, adapted not only to the length of the span, but to the riverbed, the height of the banks, the intended traffic, and local building codes. Drawings had filled entire rolls of paper with details: the exact curve of an arch, the thickness of plates in high-stress areas, the layout of reinforcement steel. On the rivers of the Eastern Front, he had adapted those habits to wartime conditions. Even then, every bridge had demanded a certain amount of unique calculation. A wooden trestle built over a narrow, fast-flowing stream in autumn did not resemble a steel structure over a broad canal in summer. The materials differed. The supports differed. The way forces traveled through them differed. Skilled workers interpreted his instructions. Here, on the opposite bank, the underlying philosophy was reversed. The Americans appeared to have selected one basic building block and then adapted the entire concept of bridging around it. Horizontal sections used the frames in one orientation. Vertical supports reused the same pieces upright. Diagonal braces, when he noticed them, were created by angling the same lattice components. It was as if someone had decided that engineering on the battlefield should revolve around a single word: repeat. He watched as one team finished tightening fasteners and immediately moved to help another group. There were no specialists visible, no one whose role was obviously different from the rest. Everyone carried frames. Everyone inserted fastenings. Everyone seemed comfortable taking over any step in the sequence if needed. Klaus understood what that meant for training. In his own units, workers needed to interpret varying plans, understand which component went where, and sometimes improvise adjustments on site. That demanded a mix of specialists and generalists. These soldiers, by contrast, appeared to have mastered a narrow, highly refined procedure. Learn how to assemble one unit, and you had effectively learned the entire system. He wrote another note in the margin of his sketch: one component, many roles. It was a concept that would not have impressed anyone in a factory back home before the war. Yet out here, under grey clouds and with artillery thunder faintly audible in the distance, it represented something close to revolutionary. The bridge, still incomplete, had begun to feel less like a structure and more like visible evidence of thinking on a different scale. Time moved differently when measured in sections of steel. By the time Klaus reached the bottom of the page in his notebook, nearly half the river had been spanned. The partially finished bridge projected out from the western bank like a solid line, its repeating lattice pattern casting a delicate reflection onto the moving water. Teams of soldiers swarmed around its base like ants on a branch, constant and coordinated. He shifted his position slightly to relieve a numb knee and watched as a new phase of work began. Up until now, he had focused mainly on the length of the structure. Now his attention turned to what lay beneath and around it. On the near shore, where the first sections met land, he could see wide, flat steel plates laid across the ground. Soldiers had placed them side by side to form a base, checking their level with simple handheld tools. No deep excavations had been dug. There were no concrete mixers, no curing piles, no heavy formwork. The foundation seemed to be a combination of weight distribution and the rigidity of the linked frames. From these plates, stacks of the same ladder sections rose vertically. Again, the pattern repeated. Identical units, identical connections. The vertical pieces were linked to the horizontal ones with the same fastenings. Diagonal members tied them together, creating a three-dimensional framework that, in his mental calculations, would distribute loads efficiently. He frowned slightly, trying to see where the limiting factor might be. Every structure had some element that would reach its capacity first under stress. In traditional bridges, it might be a particular girder, a bearing, a foundation. Here, with identical pieces repeated everywhere, the limiting factor was less obvious. If each frame could bear a certain load, and those frames could be stacked or doubled, then capacity could be increased almost like adding layers. His gaze followed the line of the bridge outward again. Near the center of the river, he could see signs that the Americans had reinforced the middle sections more than the ones near the banks. Additional layers of lattice work had been added, doubling up the frames. That would increase strength at the point of greatest bending force, a neat solution using the same basic component. Klaus recognized the elegance in that simplicity. It was not elegance of appearance. The structure was purely functional. It was elegance of idea. He had been taught to think in terms of custom fits, the right design for each unique location. The approach across the river from him suggested a different rule. Create one robust, modular solution and then apply it wherever needed, adjusting only the combinations, not the pieces themselves. He watched one team pause only briefly to drink from canteens before returning to the next task. The pace never fully stopped. Vehicles on the western bank were already queued up, engines idling, as if their drivers trusted that a way across would exist by the time they were needed. The more sections went into place, the more the entire process took on a sense of inevitability. The Americans were not racing the clock in the erratic way that came from desperation. They were following a schedule that had clearly been practiced many times before. Klaus checked his watch yet again. The predicted gap in Allied movement that planners had counted on no longer looked like a gap at all. It looked like a quickly narrowing window. The moment came when steel had to meet more than water and air. As the last frame slid into place and fastenings were secure, activity on the western bank shifted. For a few minutes there was less movement around the stacks of spare components and more around the line of waiting vehicles. Soldiers in different uniforms, drivers, perhaps, or unit leaders, gathered, spoke briefly, and then returned to their machines. Klaus raised his binoculars, heart rate subtle but noticeable in his chest. Building a bridge was only half the story. The other half lay in what it could carry. The first vehicle to move forward was a light one, a small open car with a canvas top. It rolled cautiously onto the approach, its tires compressing slightly as they touched the metal surface. The bridge did not shift in any visible way. The car drove at a deliberate pace along the span, its outline sliding over the water like a shadow. It reached the far side, turned off onto the eastern bank, and disappeared from his field of view behind a stand of trees. After that came a slightly larger truck, then another. Each one increased the load slightly, and each one crossed without any sign of strain in the structure. If there was any bending in the middle of the span, it was too slight for him to detect at this distance. He looked for side-to-side wavering, for any rhythmic movement that might hint at a vibration building up along the frame. Nothing suggested instability. The bridge surface remained steady. Vehicles passed each other at controlled intervals, forming a steady, orderly line from one shore to the other. Then the tone changed. The next machine to approach the western end of the span was broader, taller, and carried the unmistakable silhouette of armor. Even at a distance, its edges caught the light differently. A tracked vehicle rolled forward, its engine likely louder than anything that had crossed so far. The structure beneath it awaited a much more serious test. Klaus held his breath without quite realizing it. His mind began to run through rough calculations, estimated weight of the vehicle, distribution of that weight over its contact area, the likely bending moment at midspan, the reinforcement he had observed earlier. He knew from long habit that every structure deflected under sufficient load. The question was how much and whether it remained within acceptable limits. The armored vehicle reached the first section of the bridge and eased onto the metal surface. The structure accepted the weight without visible protest. Panels, linked in their lattice pattern, bore the load. Slowly, the machine advanced toward the center of the river. At mid-span, where forces would be strongest, Klaus searched for signs of visible sag. There might have been a slight downward curve, but if so, it fell well within the range he would consider normal for a properly designed structure of that length.
No sudden movements. No resonant motions.
The vehicle continued, reached the far side, and moved off. Another similar vehicle followed, this time at a slightly faster pace. Then another. After 2 or 3 crossings, the behavior of the column changed subtly. Tension eased. Drivers no longer inched forward with exaggerated care. The bridge was now part of the landscape, just another piece of equipment doing its job. Klaus let out a slow breath and lowered the binoculars. Above the distant river, faint trails of aircraft exhaust hung in the sky. On his side of the bank, the air remained still. Somewhere behind him, an engine started up, then died again, as if someone was having trouble coaxing life into an old truck. The river crossing no longer looked like an experiment. It looked like a functioning corridor. He thought of all the scenarios that had been discussed in briefing rooms. How long could Germany hold the Western industrial regions if the Allies were kept on the far side of the Rhine? How much time could successful demolitions buy? How many days would it take for new defensive positions to be supplied and manned if the enemy had to rebuild capacity from the ground up? Watching the steady stream of vehicles now crossing the bridge, Klaus realized that those questions had already been quietly rewritten. A movement downstream caught his eye. He turned the binoculars slightly, following the line of the river as it curved away. The water reflected the cloudy sky, broken only by small ripples and the occasional dark form of floating debris. Then another shape appeared on the far bank, familiar now, despite the distance. Another team of American engineers was at work, several kilometers away. Trucks. Stacks of the same steel frames. Soldiers moving with the same practiced rhythm. It took him only a few minutes to confirm what his intuition had already suggested. They were building a second structure of the same type. For a moment, Klaus simply watched in silence, the binoculars resting lightly against his face. One modular bridge had been enough to challenge his expectations. A second, rising in parallel, pointed to something larger than a single impressive feat. He tracked the process, recognizing each step now that he had seen it at close attention upstream. Placement of base plates. Assembly of the first horizontal frames. Vertical supports rising as the span advanced. Teams moving in patterns that no longer looked mysterious, but still remarkable in their consistency. If one team could produce a major crossing within a single day, what could multiple teams achieve along the entire length of a front? He closed his notebook and pressed the back of his pencil against his lip, thinking. The German efforts to remove major crossings along the river had taken months of planning. Surveyors had studied structures years old. Demolition crews had placed charges carefully, ensuring that when the time came, spans would fall in ways that made simple repair impossible. Those collapsed arches and twisted girders had been marked on headquarters maps with red symbols, each one representing an obstacle intended to slow an opponent by many days. The idea had seemed sound: interrupt the network, and movement would stall. But what if the opponent did not need the old network at all? Klaus pictured the map he had seen last: red symbols where bridges had once stood, blue lines showing intended defensive deployments. He imagined overlaying a different set of marks, potential crossing points every few kilometers, each one not tied to a permanent structure but to the capacity of engineering teams and the supply of standardized components. Instead of thinking in terms of individual bridges, he now thought in terms of a system that could be deployed as needed, in multiple places, almost like a set of portable roads. He felt the first real wave of unease. It was not panic. He was not the kind of man who easily lost composure. It was the awareness that he had just seen, with his own eyes, a capability that did not fit into the mental models used by his superiors. Strategies built on assumptions of limited crossing points were suddenly dealing with a different reality. Flexible crossings, repeated at will. He opened the notebook again and began to write longer sentences rather than short notes. This time, he was not sketching steel patterns or dimensions. He was outlining implications, points that needed to be communicated beyond technical circles. As vehicles continued to roll over the first bridge upstream and the skeleton of the second grew steadier downstream, Klaus understood that what he had been observing was not just a clever piece of engineering. It was a visible expression of something larger, an approach that treated complex tasks as a matter of repeatable processes rather than unique art. The river was no longer the only thing dividing the two sides. A different kind of gap had opened up in his mind, one measured not in meters, but in methods. By the time Klaus reached his unit headquarters that evening, the light outside had faded to a dull blue. The building that housed the command staff was an old structure pressed into military service. High ceilings, creaking floors, windows darkened against possible air raids. Inside, maps and charts had transformed it into a place of planning rather than domestic life. He reported to the operations room as instructed. The atmosphere was tense but controlled. Voices were low, movements purposeful. At one end of the room, a large map of the Rhine region covered the wall, marked with pins and colored lines. Near it stood the unit commander, a colonel whose uniform bore the insignia of long service. Klaus approached, saluted, and waited. The colonel finished a conversation with another officer, then turned. "You observed the enemy activity at the river?" the colonel asked without preamble. "Yes, sir," Klaus replied. "American engineering units on the western bank. At least 2 major crossings under construction in our sector alone." The colonel gestured to the map. "Report." Klaus stepped closer and began to describe what he had seen, choosing his words with care. He detailed the use of standardized steel frames, the way teams handled them, the absence of heavy machinery, the speed of assembly. He explained how the temporary foundations relied on broad base plates rather than deep groundworks, and how vertical supports used the same modular elements as the horizontal spans. He described, in neutral terms, the load tests he had witnessed: light vehicles first, then heavier trucks, then armored vehicles. He noted that the structure appeared to perform within acceptable limits under these loads, with no visible instability. The colonel listened, expression unreadable, occasionally glancing at the map. Other officers in the room drifted closer as the report continued, subtle shifts of attention indicating the growing significance of what was being described. "How long from the first frame to the first armored crossing?" the colonel asked finally. Klaus consulted his notes. "Approximately 8 hours, sir. They began in the morning. By late afternoon, the bridge was fully supporting regular traffic." A slight ripple of surprise moved through the small audience. 8 hours was a number that cut through professional language. It was easy to compare with earlier assumptions. "How many similar teams did you see?" another officer asked. "In my visual range, 2, Klaus answered. "However, based on radio intercepts and other reports, it is likely that similar activities are occurring at multiple points along the river." The colonel studied the map more closely. Red marks indicating destroyed permanent bridges dotted the line of the river. Blue formations showed German units assigned to specific sectors. The defensive plan relied heavily on the premise that these red marks represented significant barriers to the opponent. "And your assessment?" the colonel asked quietly. Klaus hesitated for only a moment. He knew that what he was about to say would not be pleasant to hear. But he also knew that avoiding the conclusion would serve no one. "Sir," he began, "the opponent appears to possess a bridging system that can be assembled rapidly by non-specialist troops, using standardized components. With sufficient stock of these components and enough trained teams, they can create new crossings in a fraction of the time required to rebuild permanent structures. Strategies based on the assumption that removed bridges would delay them for several weeks are no longer accurate." Silence settled in the room for a few seconds. The colonel's jaw tightened slightly. He looked again at the red marks along the river, then at the blue formations behind them. "In other words," he said slowly, "the obstacles we counted on may no longer be obstacles." "Not in the way we planned, sir," Klaus replied. No one raised their voice. No one argued. Yet the air in the room seemed heavier now, as if a new weight had been added to everything already resting there. The colonel nodded once. "You will prepare a written report with full technical details and your recommendations. It will be forwarded up the chain at once." "Yes, sir," Klaus answered. As he turned to leave, the murmur of voices resumed behind him, this time with a different tone. The map on the wall was the same as it had been an hour earlier. The symbols had not moved, but their meaning had shifted in a way that paper alone could not fully capture. The headquarters building had grown quieter by the time Klaus sat down at a small wooden desk with his notebook and a blank sheet of official paper. Somewhere in the corridor, footsteps echoed briefly and faded. Outside, distant sounds from the front, artillery, engines, shouted orders, filtered through the walls in softened form. He drew in a slow breath and began to write. His training guided him first toward description. He outlined the physical characteristics of the bridging system: modular steel lattice frames, uniform dimensions, standardized fastening points. He described how these frames were used in different orientations to form the deck, the vertical supports, and the diagonal bracing, all with the same basic component. He detailed the assembly process: number of personnel per frame, average time per installation, lack of heavy lifting equipment, reliance on manual handling made possible by keeping each unit within a manageable weight. He emphasized that the process allowed for multiple teams to work in parallel without complex coordination, accelerating overall progress. From there, he moved to performance. He recorded his observations during the initial vehicle crossings, noting the apparent stiffness of the structure, the limited visible deflection under load, and the absence of noticeable vibration even under the passage of armored vehicles. These were the points higher commanders would look for when judging whether this was a minor field expedient or a serious capability. Only after establishing these technical elements did he turn to the larger implications. In measured, clear sentences, he explained that traditional estimates for how long it would take an opponent to restore major crossing capacity across a large river assumed the need to reconstruct permanent or near-permanent bridges. Those estimates were no longer valid in the presence of a system like the one he had witnessed. Where earlier planning had treated each destroyed bridge as a unique obstacle, he now suggested thinking in terms of how quickly modular spans could be deployed wherever conditions allowed. The bottleneck would not be engineering design, but the supply of standardized parts and the number of trained assembly teams. He highlighted one strategic consequence in particular: attempts to deny crossings by focusing solely on the demolition of existing structures would produce sharply diminished returns. An opponent who could rapidly deploy entirely new structures would be inconvenienced, not halted. In place of previous emphasis on destroying spans, Klaus recommended redirecting efforts toward contesting the approaches, areas where vehicles would concentrate on either side of the river. Artillery, obstacles, and defensive positions would be better used to disrupt the formation of bridgeheads and the gathering of traffic, rather than trying to remove structures that could be rebuilt in short order. He chose his words carefully when addressing a sensitive point: the underlying difference between his country's approach and that of the opponent. He did not couch it in moral terms, only practical ones. Industrial capacity, he wrote, was now a decisive factor shaping battlefield engineering. The opponent's system was not just a design, it was the product of a large-scale manufacturing effort capable of producing countless identical parts, distributing them along enormous distances, and training thousands of soldiers in their use. Germany, at this stage of the conflict, could not easily mirror that effort. Factories had been damaged or repurposed. Transportation networks were under strain. Training pipelines had been shortened. Even if the basic design of the modular bridge became known in detail, reproducing its effects would require more than drawings. It would require an industrial foundation that was increasingly difficult to sustain. He ended the report with a short conclusion that avoided dramatic language. The bridging system, he wrote, represented a shift from viewing bridge construction as a specialized engineering art to regarding it as an industrial process that could be repeated almost anywhere. Strategic planning that did not account for this shift risked relying on delays that would not materialize. When he set down his pen, the lamp on the desk had burned low, casting a soft circle of light on the finished pages. He read them over once more, correcting a phrase here and there, then signed the document and placed it in the folder for forwarding. As he left the room, he understood that his report might pass through many hands before reaching those with the authority to adjust large-scale plans. And by the time any changes could be made, events along the river might already have moved beyond diagrams and projections. Still, he felt a small measure of clarity. Whatever else the future held, he had named what he had seen. Days later, when word filtered back that crossings along the Rhine had multiplied and that Allied forces were advancing in depth on the far side, Klaus was no longer surprised. The news did not arrive in the form of a single announcement. It came as scattered fragments, messages about units withdrawing sooner than expected, reports of opposing vehicles appearing in places they had not been forecast to reach so quickly, quiet acknowledgments that certain defensive lines were already being bypassed. In conversations among engineers, the topic of the modular bridges surfaced more than once. Some had now seen them with their own eyes. Others had heard descriptions from colleagues. The name Bailey, attached to the design, began to circulate in technical circles, though it remained just a name to most. For Klaus, the image of the first bridge he had watched stayed especially vivid. Not the structure itself, though he remembered its repeating pattern well, but the way it had transformed from a pile of frames on a riverbank into a functioning roadway in less than a day. The memory carried with it the hum of engines, the steady tramp of boots, the muted clatter of tools. Later in life, long after uniforms had been folded away and the front lines had receded into history, he would sometimes encounter references to those bridges in articles or photographs. Some had been adapted for civilian use, carrying ordinary traffic over quiet rivers in peaceful landscapes. Others had been disassembled, their components stacked neatly in depots or melted down to become part of other structures. Each appearance reminded him of what he had understood that March morning, that the design's true significance lay not only in its technical merits, but in what it revealed about a broader way of organizing effort. The system he had watched in operation showed how a complex task could be broken down into units small enough for ordinary soldiers to master quickly. It showed how standardization could turn a shortage of expert engineers into a manageable problem. It showed how manufacturing, logistics, and training could be aligned so that a river, once a formidable barrier on maps, became just another challenge to be handled with practiced routines. The conflict in which he had taken part would later be described in many ways, by campaigns, by political decisions, by human stories from countless perspectives. For Claus, one quiet memory of engineers at work on a cloudy day by the Rhine remained a personal lens on one of its underlying truths. He had entered the war believing that engineering was about singular solutions, carefully tailored to each location, each set of conditions. He left it aware that in an industrial age, the side that could create effective solutions that repeated easily often held a decisive advantage. The image of the Americans lifting steel frames in unison stayed with him not as a symbol of defeat, but as a lasting example of how a well-designed system could alter the practical meaning of time, distance, and obstacles. Where older thinking had seen a destroyed bridge as a delay measured in weeks, the new approach reduced that delay to the length of a workday. The title that might later be given to such a story, about a German engineer watching a 60-meter bridge rise in 8 hours, would capture only a small part of what had unfolded. For the man who had stood on the eastern bank with a notebook and a pair of binoculars, it had been less about the specific span and more about the realization that he was witnessing a different way of conducting war, built as much in factories and training grounds as in planning rooms. That realization, quietly recorded in a field notebook on a cold March day, was his enduring bridge between the world he had known before and the one that emerged after.